Okay, welcome back to my channel. Today I'm going to continue the engine shaft balancer project, which is right now we are going to create the half of the engine shaft balancer. And because usually when we want to manufacture this part, we have to create the half, and then we create the casting mold for the particular cases. So I'm want to demonstrate here is how we can create this half of the section, and then create the toolpath like this, and also I will show you a little bit about the how this thing going on the machine CNC that I already machined this part previously. Okay, let's get started. Okay, first of all, I would like to open my project. This is the project that previously is created in my last video. Okay, if you want to know how we create this part, so you can check the part 1 of this video. Okay, as you can see here, we want to, this is the final part that we want to create, but right now, as we want to create the just for the mock-up mold, so we want to modify all those parts, all those feature here, like a keyways feature, and then also the shaft feature we want to remove, but we don't want to remove all the history. So what we're going to do is to create the derived part. I click derived part. Basically, if you create derived, you create the same exactly part from this point. So everything that you modify in the derived parts, it cannot affect on the original part or on the top level priority part. So this one I want to create a new design. I click this one, and then what kind of the derived that you want to like. If you just want to derive the model, you click here the model. So inside it is just only the body itself, but if you like to create the one component as a design, you can click the one component as a design, and as you can see here, you can also derive all your sketches, all your construction plan, and etc. But this time I only want to derive just the model, so I just click that model. So just this one body, and then I want to put it in the new design, so I click OK. So this is, as you can see here, is an untitled design. I'm going to save first. Okay, shaft machining. Okay. So as you can see here, we cannot see the history because it's a derived part. So what I'm going to do is I want to split this part with the split body to split this one, and then the splitting tool will be the plane here. Okay. Oh, before the split, I want to defeature this one. Okay, because I don't want to machine this one as a final part. So because of this one is a project from casting, so I need to remove all the feature. I just click all the feature here. Okay, click all the feature. Okay, and then I just click delete. Okay, delete the face, and also I'm going to remove this feature, delete. And I'm going to press pull this one, okay, until here. Okay, finish. And then this one as well, I'm going to remove the feature first, the chamfer, and then also using the press pull from here until here, and then again from this part until here. Okay, so this is basically just finish the defeaturing, and then I'm create the split body. Click here, and then I use this plane as a splitting tool. Okay, so it's consists of the two body, one body here and the other is a body here. So I'm just going to use this part of the body, half of it. So maybe this one is I rename, okay, shaft, and then I'm going to create a bit of extrusion here. So I click this one, I create maybe 3mm extrusion to give me a space a bit for a machining. Okay, and then I create a plane here. I create the raw material, would be 200mm, and then you can just position the circle, but in this case I just want to position is not I just put in the roughly in the center. Okay, and then I extrude this as a base of my material. Maybe 10 is enough. Okay, and then I put the fillet to show you, because I want to machine all this using the ball nose, so ball nose will leave the fillet. So maybe I use the 2mm of the fillet. Okay, I think the preparation is good enough. Okay, and then we're going to continue to the manufacture. Okay, just click the manufacture, and then I'm going to create the setup. As I want to use the relative size of the setup. Okay, as you can see here, the setup is not aligned correctly, the axis, because the z-axis at here. So we can select the orientation. Okay, I'm going to use the z-axis and the x-axis. So I'm going to click this one as a z-axis direction, and then I will flip the z-axis over there. Okay, yeah, okay, here I think it's good enough for the position. And also I can flip the x-axis. I want the x-axis is over there, and then the stock, I want to not to offset the radial stock, so just click 0, and then the front offset I will have a 1mm offset, so I leave a bit 1mm on the top of the model. Okay, the setup is perfectly aligned, and then okay, I think it's good enough. Okay, and I will start to using the adaptive clearing and select the tool. This I will make from plastic, so I'm going to use the end mill flat. Okay, end mill flat. Okay, for the first roughing, and then the geometry. Okay, this is not the best machining, so the stock contour, okay, that one, and also the height and also the passes. So I will leave it 10, maybe not 10, 8mm for the maximum load, and then climb, and then maximum roughing strategy step down is 10. Fine, maybe because it's roughing is just only 1, and the stock to lift I will leave maybe 0.4 for the radial and axial stock to lift. Okay, just click okay, I will see here. Yeah, I think it's good enough, and then I just click calculate, so they will automatically calculate the toolpath. Okay, this is the toolpath, and then next thing I want to use the horizontal clearing to to face this flat surface, I still use the 25 as a reference of the tool, and this one maybe I will leave it 10 millimeters, so it just machine only through this surface. And also I will limit the bit like this, so I just want to machine between 28 and 10. Okay, and then minimum cutting radius. Okay, I think stock to leave 0. Okay, I think it's good for now. Okay, they are calculating. Okay, so this is the flat area. Just machine all the flat. Okay, let me check for the stock to leave. Oh yeah, there's 0 stock to leave. Okay, so we have 2 tool pad already, and then for the 3D part here, I'm going to use the Scallop. Okay, I'm going to use the Scallop, and I will choose the 3D profile operation using the 8 millimeter ball nose. Yeah, this one. Okay, but if you can see here, I think the ball nose is too short, so I'm going to edit the length. So maybe 40. I think 40 is good enough. Okay, yeah, 40 I think is good enough. And then I will leave all the fit and speed parameter according to the data provided by the Fusion. And then I just want to create only the I think I use the selection here, boundary, to just want to make sure the containment is just inside here. And then I think I don't need the additional offset. Okay, and okay, for the tolerance 0.01, step over I think I use 0.3, and then the down milling. Okay, from outside to from inside to outside. Okay, let's see what's the result here. They're calculating the toolpad. Okay, yeah, okay, I think the toolpad is finished. But if you can see here, I can use the linking like this way. I'm going to use the shorter path, so you can see the difference when we use the shortest. So the Fusion will only consider about the linking the toolpad using the shortest path, I mean, so the machining time will be reduced. Okay, and then the last one, let me see the result from the simulation first. Okay, simulation, I need to let me rewind simulation, and then let me open up the stock. Okay, standard, and this is the operation. Okay, I think it's good enough. And when you click here info, the Fusion automatically will verify the toolpad first before we, in the background I mean. So this is the progress of the verification of the collision check. So yeah, this is, if there is any collision, they will show here with the red notice. Okay, so okay, that's I think I'm going to speed up a little bit. Okay, I use tail. Okay, so this is the first second operation here, and then this is the third. I think I will turn off the okay. So basically they just doing the scallop machining on the surface. Okay, now it's a finished toolpath. Okay, as you can see here, if I zoom, so they just left the corner radius which unreached by the previous tool or the bigger tool, so we need the smaller tool. Okay, so in that case I will use the pencil machining here, and then I will select the smaller tools. I use a plastic here, operation 3D profile, and I will select the ball, 4mm ball. Okay, and also to edit the tool, this one maybe 40. Okay, to make sure the tool is safe. And then okay, I just use the silhouette for the containment and also the passes. Okay, so this is that we have to adjust this P10C angel is I will use 25. Okay, the step over, number of step over maybe 8, and the step over 0.2, and the direction would be down milling, and the shallow angle would be 10 degrees. Okay, let me see the result first. Okay, calculating toolpath. Oh, it's already finished. Okay, so this is the toolpath. Okay, yeah, this is the toolpath. So I also want to use the shortest path for the linking. Okay, yeah, let me do the simulation from beginning. So maybe I'm going to pause this one. Okay, I'm jumping to the last simulation for here. Only this is the last. I'm going to simulate the result from this toolpath. Okay, let me play this. Okay, its simulation is finished. As you can see here, all the surface is perfectly machined. And then let's continue to the post processor. Oh, here, yeah, create NC program. Okay, for this particular NC, and then which one is the operation? I think it's all the operation. Okay, so I'm going to create the post process for this one. Okay, you can view the code here. Okay, all the code here. Okay, and then let's see how this run on the machine.